container security and their APIs. About 18 months ago, 16 months ago, we at Cisco bought a company called PortShift. I don't know if any of you knows PortShift. PortShift is about cloud native security. Fundamentally, it's about making sure that your container is secure, making sure that you deploy this with the service mesh, make sure that you integrate this with CI/CD. Over the course of the last 16 months or so, we've greatly expanded on the capabilities of PortShift. So what I'll be showing here today, and I hope I have a little time to give a live demo. What I'll be showing here today is what we did with PortShift and where we took it. The reason I'm talking about container security and APIs in one sentence is that if you think about this, I can secure my entire container stack. I can make sure that I don't have vulnerabilities in the images. I don't have vulnerabilities in the image layers. But on top of that is a piece of real software implementing the application logic of your enterprise. There can be vulnerabilities in there, 0 days. And I can have vulnerabilities in the APIs that sit on top of that. So the reason for talking about these APIs is it's really about that duality between API services and containers. So I'm Peter. I'll skip over this. In the interest of time, I'm going to be talking about Panoptica. For those of you who are interested, go look it up on Wikipedia. It has some connotations that we may or may not want to repeat here. But besides that, really where we play is where we started is that we integrated with runtime, the runtime in Kubernetes. So you really would like to make sure that your cloud native infrastructure is secured. Integrate into Kubernetes. Make sure that you have a mutating webhook. Make sure that you integrate with the service mesh. Make sure that all of the communication channels between individual containers in pods are properly secured. And we integrate with CI/CD. We integrate with IDEs even. And we do all of this type of integration just to make sure that we actually understand what the application is doing as it's deployed out in Azure, GCP, or AWS, or even in an on-prem deployment. Because if I'm building even a simple application, and I have a demonstration of a sock shop, I already get 15 containers written in 3 different programming languages, written with IDLs in between, and you have no idea what the application is doing. So how are you going to secure that application if you don't even can figure out what the application is doing? How did we get here? So when I learned to write, when I learned to program, well, when I still didn't have gray hair, the application was really built as a piece of logic, sitting on top of a series of libraries, sitting on top of an operating system and a networking stack. You could still read the code and try to figure out what it does and fix that code for whatever purpose. And that lift and shift into a virtual machine, that didn't really matter very much because the only thing you did is pick up the entire application stack and stick it into a hypervisor process, and that's it. Nothing really fundamentally changed. What did change, though, is by the time we get into containers, microservices, and all of these nice buzzwords that are associated with that. And the key here is really depicted in this on the right-hand side. So before, I have one piece of software stack that is easy to understand. Now I get a virtual machine, a container, application logic sitting inside, and a service endpoint on top. Back in the day, we used to call them RPCs, and they're still RPCs. And with these RPCs, I can now connect into deployments that are hosted directly on containers. I can connect into, or serverless functions can connect into me. But all of a sudden, I have a very large attack surface. What used to have just a few interfaces now will have very many interfaces, and with the developer being able to program and build and deploy by themselves, there's actually a rapid pace by which these applications are deployed. The problem 40 years ago with RPCs was authentication and authorization and the definitions of interface definition languages. Now we call them APIs. These problems are still not solved. You cannot believe what kind of problems you'll find from an authorization perspective inside code. The only fundamental difference is that the scale is just massively higher. So if I'm a security person, I wouldn't even know where to get started with this. We've built a series of fuzzers on the API level, and you poke that at a bunch of services, and the types of authorization problems that creep up are just staggering. There's a wonderful video online, and unfortunately it's not done by us, it's done by a competitor of ours, where the professional hacker, and he actually went to jail for this, managed to just break into 55 Bitcoin companies. And admittedly, 54 of them had exactly the same software libraries. So as soon as you fix that, you fix the 54 issues. But what she did was actually fairly straightforward. You have your iPhone, you communicate with your Bitcoin bank, you pick up all of the messages that go in between the client and the server. You analyze these APIs. You analyze what messages and what data you're transferring, sending between your iPhone app and a backend app, and you find that there are actually account numbers in that. And you then ask yourself, what happens if I just change that account number? I'm authenticated for user Peter, but if I were to change that to even though I'm authenticated as Peter, if I happen to know Jonathan's account number, and I would fill that in, chances are it would just work, and I just get your information. You move money around, you change PIN codes and whatnot. Those are the types of problems that you'll find at that API level. And the reason it's important to talk both about containers and APIs is that it's really that condensed stack. Even if I have a completely secured container stack, if I leave the API open, I've basically built a very secure house, and I've left the front door open. So that's why it's important to talk about that entire stack, because one of the things that you start to realize is this. If this is a depiction of the internet, then the wide open internet is really the runtime for all of your apps. I just built an app. My developer will just throw it out into AWS, GCP, or Azure. If we're lucky, it sits behind an API gateway, but that's not a guarantee. And that attack surface is now massive. It means that if I have 10 containers inside my application, and even though my payment container, my order container, my cart container is perfectly secure, if I happen to have a logging daemon on the side that I haven't secured, I can still get into the deployment. So it's basically a perfect storm. We want to go ever faster and faster to build code. Developers are in control of deploying the applications. Developers have not been taught to think about security. We lack the tools for observing what the application is doing. And from my own experience, writing authorization code and writing authentication code is just hard. So in that sense, it's a perfect storm. So with this in mind, we started to think about a new way to really secure the applications, all based on the Portshift acquisition. That's really where we started. And basically, there are 4 sets of questions that we asked ourselves. How do I protect cloud-native applications in the first place? I must really rely on the application's own defenses. I can't rely on a Cisco IDS, IPS, or firewall. They're not there inside AWS, Azure, or GCP. Then you start asking yourself, is the application configuration sound? What software am I really using? It's great if you think about that a modern BMW today has about 200 million lines of code, 80% of which is just open source. If I were a hacker, and I'm an associate professor at the university as well, if I were a hacker and I'm going to ask this to my students to see if they can do that, start poisoning the GitHub repo. So then, can I actually come up with an experiment where I poison the GitHub repo, open source, and I'll just wait. Half a year from now, I'll start seeing my code that I've poisoned creep up in all sorts of products out there. So do I even know what software I'm running inside my application? Can I attest to this? Can I do a software supply chain? Do I actually know what software bill of material I have in my application? Can I build a barrier inside my application? And this is, of course, the linkage to service meshes. Can I actually extend my application so that at least I get that secured layer where I know something about the certificates that go into the deployments, where I'm assured that I set up TLS 1.3 sessions, where I'm assured that if I do not, if a communication path between two containers do not adhere to enterprise standards, that at least I have a component that will stop these connections. And can I do that automatically? Because if I'm an engineer, I may have 2 or 3 applications under my control. If I'm an organization with a security team, I may have thousands of applications out there. So I actually do want some automation to at least get the 95% of the common mistakes handled. So that's really where we come in. That's really where we've taken PortShift, Panoptica. And really, it's exactly what that sub-sentence says. It is a single pane of glass for all things cloud native app. So Panoptica comes from Panopticon. It's associated with George Orwell. I did have my reservations there, but that's besides the point. But as a point in reference, it's actually not a bad connection point, because what you would like to do when you're building secure cloud applications, you would like to know what the application is doing, when it's doing, how it's doing. Are there anomalies? Can I detect those anomalies, and whatnot? So what Panoptica does is we present all of the artifacts that go into the solution. So for now, with the release we have now available in PLG, product-led growth, free tier, is basically we scan for workloads, APIs, and serverless functions. We're going to extend that towards new areas soon. We're going into data, making sure you actually understand what data you're being transporting between each of these components. But it actually gives you that feel for what the application looks like. So we control containers, images, software bill of material, supply chain, serverless, and API. So serverless is interesting as well, because serverless functions are being fired off at the AWSs out there. And we found ways whereby even if you scan, well, once you scan the image, or so once you scan the serverless function for vulnerabilities, there's a password hidden inside, there's a configuration issue inside the serverless function, we actually can find, we found a way to stop AWS from firing those serverless functions. And then you can get a little bit more control how you deploy those applications in the cloud. You would like to manage the risks. So I'm sure that you've heard about the MITRE ATT&CK vector, basically a series of areas where vulnerabilities can creep up. But basically, we've taken our container security and placed that under that MITRE ATT&CK vector, which means that you can now actually get for each of these areas insight into the issues for the area. And then lastly, and some say it most importantly, some others say it's the least important part. You can actually enforce policies as well. Some customers are telling us, just give me the visibility. Just tell me which parts of the applications are vulnerable, and I'll take care of the rest. Some customers are saying you actually would like to make sure that you report, you block, and whatnot. So that's what Panoptica is. There are 2 key components. Now there are 2 key components. The third one is being built to Panoptica. First one is KubeClarity. It's an open source package that is out there, and that will help you scan the vulnerabilities in images. It's an active package. It was based on KubeAI, and it will help you simply go through all of the issues within images and image layers. It will actually allow you to plug in your own scanners to give you a little better insight in what the issues are with the solution. And we've recently extended that with software bill of material analysis, so we know what parts go into the application. And we're going to extend that with the software supply chain. It's out there. At the last slide, I actually have the links where you can get it. And then recently, we've released API Clarity. API Clarity is really to give you that insight into all of the calls between the various components inside your application. It will help you understand which APIs you're using. And you think that's an easy one, but actually it's not. Because if I were to use, for instance, a third-party service, and I do that by incorporating a library, I can scan my code, but that still doesn't give me any visibility to what APIs are being used, because maybe that API is being called right from underneath me in an image library. So API Clarity actually gives you that insight. And it allows you to analyze it. It looks for PII in the application. It looks for broken authentication in these issues. And recently, and this is as of 2 weeks ago, we released it at KubeCon, we allow fuzzing and testing based on Microsoft Wrestler. And it's really here to build that entire pipeline. You find vulnerabilities at the start. Once you've found the vulnerabilities here, you can then start testing these services so that these vulnerabilities pop up again for potential risks. Let me skip over this one. This is about KubeClarity and what it does. I really wanted to go into this one because this is a talk really about APIs in the stack. The 4 questions that we've asked ourselves with APIs is, what APIs do you have in your deployment? Like I said before, it's a more difficult question than you think. What third-party APIs are you using? Are you using Grafana Labs, Mailgun.net, or any of the other Twilio.io for third-party services? Are you actually exposing PII over those services? What can you tell about those services? Do they happen to run and are they well managed? Have they been running for years, or are there issues with those services? Are they geofenced? Then if you look inside the APIs, the things that we run into are the use of deprecated API methods. Issues where a developer has simply moved on and defined a series of new API methods but forgot to take out the old ones. And if you have deprecated ones, are they insecure? Well, is the API itself, does it have a terrible uptime? Are they based on broken implementations or broken infrastructure? And do this across thousands of applications, if not tens of thousands of APIs. We talked to one of a car manufacturer a while back, and we're actually demonstrating this kind of replica of what these guys have done. But these guys are managing 40,000 API methods on a daily basis. 40,000, and imagine these are APIs that actually connect into those cars. So it'd be kind of odd if a hacker comes in and all of a sudden thousands of cars start having their infotainment system being broken. So in such an environment, it's important to make sure that your APIs are secured. So API clarity needs to be frictionless. It really should be a Wireshark of APIs. It needs to be automated. You need to be able to construct open API specifications by observing API traffic. The reason that is important is that very much of the analysis of the applications and their API implementations is based on having a specification. In most cases, the developer doesn't upload the specification. So how do you actually know what to test? So for that, we actually put it together in a dynamic fashion. Reconcile and drift. As the application is being developed on a daily basis and the developer is working on their code, it's actually incredibly important to understand what parts of the application are being changed. Because if you know what's being changed, you also know where you're going to attack first. And very many of these applications that we're building, like API Clarity, can of course be used for good use and nefarious use. We know that. Zombie and shadow APIs. So zombie APIs are those APIs that are left over. Shadow APIs are those APIs that are intentionally left behind for IT to come in and fix things in the solution. And in both cases, you actually would like to know that they're there and what the issues are with those APIs. And then testing, fuzzing is important to really get a sense for whether you have an authentication issue, an authorization issue, whether the server throws you a 500, when you send particular nonsense to a service, and whatnot. And of course, you'd like to make sure that you present this into a decent form. So what it looks like is basically like this. It's a simple dashboard. It shows you all of the APIs that are used in the application. It shows you all of the differences that you found in the specifications, like zombie APIs and shadow APIs. It shows you which of the APIs are being used at a particular time. And I can actually, if I have a few minutes left, I can show that. But it's the first step in getting there. You would like to analyze the specification. If the Open API specification is there and it says that an array is only 16 bytes long, then that's a good thing. But very often, developers upload their specification and leave the array length completely undefined, which means that if I'm now building a fuzzer, that's exactly the first point that I'm going to test and try to break the application. You would actually like to run the fuzzer that we have and test the business logic as the application is running. It's one thing to do static testing if you have the sources, but it's so much better to do this when the application is active. In fact, one of the things that I challenged the team with is whether we can do some form of chaos engineering. Can I actually run that fuzzer when the application is up and running and actually transacting? Wouldn't it be nice if you're building, who knows, maybe United, and you know that during the day you're going to try to break those services. Because if you can break it, somebody else can break it too. And of course, you would like to make sure that for best practices, once you start with that specification, you generate that client and server code right from the start for that testing. That's just one step. But can I then also, once I've done that, and now citing that work that our friends from the car manufacturer have been doing, can I actually protect and track applications from cradle to grave? Can I actually build that entire software development lifecycle? Can I make that one-stop shop for all of the things that are being used inside my enterprise? And again, you can ask exactly the same questions. Are my applications compliant with company rules? How about industry rules? Can I actually do that kind of testing? How do I track that? How do I track the changes in my applications and my APIs on a daily basis? And how do I test for regression? So in this particular case, what we developed is an API for an API. Yes, it's a palindrome. An API for an API is done jointly with our friends from DevRel, who are present here as well, and CX Cloud. And an API for an API is really about building that entire pipeline from integrating into a CI/CD pipeline for an application. Make sure that the application is being tested, make sure that the application has proper definitions for APIs, making sure that there are no issues with the specifications. Then upload the application and deploy it inside AWS, GCP, or Azure. Program, in this particular case, a Kong API gateway, and make sure that there are no security issues with that application. But now that I'm running the applications, I will be getting real-time telemetry from that application in that entire pipeline. And if I start to find anomalies in that application, I can also decide to take it out again automatically. Very often, pipelines are just one-way streets. You start it, developer says go, and by the time you're done, it's deployed inside an API gateway. That second part is often not done. When you start to find issues that are there for runtime, you actually would like to take it out and decommission it if policy rules say that, or at least alert on it, or block certain kinds of transactions. That's what we're demonstrating. I believe there's today there's a plenary session about an API for an API. Grace is talking about this. But the idea is that by KubeCon North America, we make this available at least as open source machinery. So in terms of API security, in one boring slide, this is what we do. So this is a word for the sponsors, I would say. This is what we're really doing. If you look at that application, that blue application out there, everywhere where there are red bars, that's where we protect the application. We protect it inside API gateways. We protect it for east-west traffic. And we protect it for those services that are externally consumed. And I'll show you that in a minute. We do that for specification and reconstruction and analysis, third-party API classification and scoring, internal service security posture. We do token insertion so that when I'm consuming services, let's say from PayPal, and that's in the demonstration, PayPal requires a token. Where do you leave that token? I can give it to Kubernetes, and Kubernetes will give it back to me, or I can stick it into a vault, which is what we've developed for this solution. We test APIs, broken object level authorization, broken function level authorization. So objects is that example that I was just describing where I'm using Jonathan's account number. BFLA is a case whereby I'm just misusing the implementation and I'm actually going to execute a series of functions inside a server with an authentication token that is not mine. We do guessable ID detection. Imagine that I'm going to this particular car manufacturer's site and I can guess that it's going to be this particular car, this particular brand. Oh, and by the way, I know the VIN ends at 324. That'd be awesome if it's there, but I actually would like to protect against it, because if it's there, the only thing I need to do is build a bot that will just scrape all of these APIs for hooks. Non-learned ID detection. Imagine that you're using a UUID to describe an object inside that service. And imagine that all of a sudden, out of the blue, sorry, I'm going to pick on you, Ismail all of a sudden says, I'm going to do a call, and here's the UUID. But there's no way you could actually have learned that UUID by just guessing. That means that you may actually be misusing, and I would actually like to make sure that we detect that. You're a new user. We'll stop you right at the door. Fuzzing, application service modeling, and dasting is important. But it's only one thing to have all of this functionality. To make matters actually work, we integrate into Envoy. We integrate into Kong, Tyke, Glue, although I do believe that Glue, take that with a grain of salt, but Kong, Tyke, and Envoy are definitely supported. We do this for virtual machines and gateways and containers for east-west traffic. It's all open source. The only difference between Panoptica and the open source version is that we've wrapped it up inside a solution, and it actually gets memory. And we do this for OpenAPI v2 and v3. And gRPC, we have a prototype of that, in all honesty. This is where to get it. So the open source versions are the first ones, API Clarity, and I think the second one is now called Kube Clarity. Within Cisco, we've actually decided, or within ETNI, we decided to create kind of an umbrella open source track. It's called Open Clarity. And inside Open Clarity is API Clarity, Kube Clarity. We're working on a new one called Data Clarity. We'll get API for an API under that as well with an equivalent type of name. You can try Panoptica right now. It's PLG, product-led growth. You can just apply for a free license. And there are absolutely no costs associated with it. We'd love to work with you. If there are folks in there who say, this is actually awesome, but I'm missing feature X, Y, and Z, let's talk and let's figure out if we can help each other out. And of course, there are tech blocks. Now, I'm going to stop here for this part of the presentation, unless there are questions. Then I'm actually going to give you, where is it? Is it here? No. And if I would have been here sooner, I would have actually been able to present this a little bit better. There we go. So this is Panoptica for real. So what we've done here is that we have a great application. It's called the Sock Shop. It's written by Google. If I were to have a network connection, of course. And I would enable port forwarding. And wait for a second. There we go. So I'm running the Sock Shop here, and this is this application with about 10, 15 containers with 3 different programming language, and you can buy awesome socks here. So colored socks, holy socks, bloody expensive socks for $99 with holes in them. And what you can do with them is you can order them, I can add them to my cart, And now I have $17 worth of socks in my cart. I can register myself. And this is a standard demonstration application that's built by Google. And the interesting thing here is that once you connect that to Istio with an Istio Envoy service mesh, and you install all of the Panoptica fields, these are the types of things that we've pulled out for this particular application. It shows that we have pods, APIs, and serverless functions. Now, the SockShop doesn't have serverless functions, but we made sure that we have multiple clusters that we can test. It will tell you all of the issues with their vulnerabilities at a high level. And mind you, some of this data is generated, some of the data is real. It will tell you things about role-based access control issues that we found, and it will tell you about what protected namespaces and protected pods that you have available. Where it gets interesting is what I was sharing about the K8 shield. This is the MITRE attack vector solution, and will tell you for each of these domains what kind of issues we can find. So for instance, privilege is escalation enabled. It's one of my favorite. If I click on it, it will tell me which parts of the application actually do have issues. And of course, privileges enabled is something that you don't want to have happen inside your deployment. And more importantly, I can hit repair, and it will actually, if I now hit the repair now, it will actually go into each of these configurations and deployments and fix them on the fly. I will not do that because then I need to redeploy the entire application. If I now get into the navigator and I expand all, basically, I hope you can see this. It will actually give me some of the insight to the specific application. So on the left-hand side is completely generated. So don't place too much attention to the left-hand side. On the right-hand side here is really that SockShop application, and I'll pull it to the left a little bit, and then zoom in. And what we'll see here is that first, from a container perspective, the color coding here is intuitive. It actually says that red, there are serious issues with this application. And we know that, we've done that on purpose. It also shows you the kinds of APIs that are established between the various parts of the containers. And it shows you that in this particular case, there's one third-party API that we're using, API m.paypal.sandbox.paypal.com. And you're exposing PII data over that interface. And that's something that you would like to be able to do, is of course up to the enterprise policies. So to give a little, get a little insight there, we can pull in runtime for these specific applications all of the vulnerabilities for each of the containers that are part of this solution, and it will show you the issues with those deployments, and whether or not the results are detected, and whether these are protected from a connection perspective. Similarly, I can pull out all of the connections telemetry. And if I were to get a layer 7 communication as well, layer 7 attributes here, then it would say for those connections that are actually doing HTTP requests and OpenAPI requests, it will tell you the last HTTP request that happened. So I would like to know a little bit more about those HTTP requests. So I can go into this tab, and it shows for every of the containers that we have, all of the security findings, and this goes from a workload perspective, as well as from an API perspective, as well as from a trace analysis perspective, which client workload was impacted, whether we can test the service, and for this particular case, I did test for payment, and I can fire it off for another one. So for instance, the catalog, if I would like to know if there are issues with a catalog container, I just fired off now a series of tests in the background. What really happens is that inside the cluster, we start a container. And inside the container, we start a REST fuzzer with a series of templates to try to break that service. And as you can see, it's done 0%. This is why I did the other one beforehand, so that we can look into in the results. Now we have internal APIs, external APIs. So internal APIs are those that are part of the cluster. External APIs are those that are consumed from the service. And thirdly, we have mechanisms to do token insertions. So if I go into that next level, into, for instance, payment, and I would like to know what its security posture is, then I get into this tab where I'm showing at every of these layers the issues. So for instance, at the top layer, I find 3 high-risk findings where I have internal service errors, I have authentication errors, I have medium risk findings, and I can look into the specific details here. So an authentication issue was detected by the fuzzer. The fuzzer retrieved meaningful information without being authenticated. So I can talk to this payment service, not being authenticated, and the responses are meaningful for me. This is how you leak information. This is how you can actually hack into Bitcoin companies that have not secured those environments well. The next level down is really that API specification. So for instance, you would think that things like a global security scheme would be a good thing to add into an open API specification, but it's missing in this particular case. High-risk findings are things like, hey, I actually find an array inside my application, and I haven't defined the maximum array length. So this is a great opportunity for a fuzzer to see if they can break it. Then if I go down, we also do trace analysis. So if you really want, if an enterprise really wants that, they can enable trace analysis. And as trace analysis is ongoing, we can find things that basic auth was used for communication between a client and a server. And you think, who's using a user ID and a password for those connections between APIs? And it turns out quite a few enterprises out there. Actually, one of the reason we started doing this is that one of our customers told us that they're actually sharing the same user ID password across the entire portfolio. As soon as you know that as a hacker, you can get into any container out there with them. And I will not name the company that did that. And then as we're going down in that stack, you actually get into the bottom layer for workload security and try to understand what the issues are for the workload security. Similarly, we do this for serverless functions. So for this particular case, we have a series of functions that we scan before they're deployed. One for analytics, billing, catalog, and we find configuration issues with those serverless functions. And it really gives you then an overview through, or it gives you then all of the vulnerabilities that you found in the application. Now, I started off by saying some of the vendors actually would like to make sure that they can policy control those applications. So for that, we have a tab with policies. Those policies are injected both in the Kubernetes mutating webhook as well as in the service mesh. And it helps you articulate things that you are allowing and what you're not allowing. So for instance, one of the things in this particular case is that billing can't run on finance. So detect a billing pod in case it's run in a finance environment. Other things that we do here are things like integration of tokens. Really has to do with the deployment of the application. If I have an application that requires a token in a secure vault, we can just describe a series of policies for that. And then similarly for connection rules, we have similar type of mechanisms to block vulnerable pods from communicating with PII and databases. And there can be very many methods by which you control your application. So this is what we do now. It's really, the official term is we do CWPP, Cloud Workload Protection, for cloud-native applications. We're going to dabble into, again, going back a little bit in time, virtual machines. You'd like to make sure that you can do the same thing for virtual machines because there's a whole lot of virtual machine infrastructure out there. And then we're doing two things. First, we're going down the stack, going directly into a CSPM. CSPM stands for Cloud Security Posture Manager. And things that we're going to be doing there are things like, can I if I know that I'm using an S3 bucket, or if I know that I'm using a particular AWS API gateway, can I actually find the vulnerabilities there? If I have those vulnerabilities, they actually percolate all the way back into that stack that I was just showing. It'd be great to have that blast radius to expand into cloud security environments as well. And secondly, we're also going up the stack into the data fields. So today I've been talking primarily about APIs and their instigation on container stacks. But at the end of the day, if I'm building a virtual enterprise that runs inside a cloud, they're operating on enterprise data. What can we really say about that data? What is the data lineage of that data? Where does it originate? Where does it sit at rest? Are there going to be security issues with those? So as I stated on the start of this conversation, we acquired PortShift. PortShift was container protection. We're going down into the stack into cloud posture. We're going up in the stack into data analysis. Let me stop here. 3.5 minutes left. Are there specific questions that come to your mind?
Is this complementary of secure workloads, or do you ever see it combining? I see a few things that overlap with functionality of secure workloads.
I think it's a little bit different. Secure workloads is primarily focused on virtual machine type of deployments. But we're really focused on that cloud native story. We really started with cloud native environments. We do need to work more extensively with our friends at Secure Workload. For now, large organization, we've kept it a little bit separate, but it could happen. We could. We're not doing it now, frankly. Our only way to control the connection telemetry between containers is through a service mesh. We're not doing that with the CNI yet. Now, having said that, there are some great things happening in eBPF, and there are some great things happening in the WASM community. So you can't just only have a service mesh. You actually do need to expand a little bit. Maybe at that point we should take a serious look at the CNI again.
Last question. Does the operation change when you have a sidecar?
Envoy is a sidecar. That's what we started with. And basically the two things that we did is take that logic that we stick inside a WASM filter inside a sidecar and repurpose that for API gateways as well. So that's one of the things that we're doing. You may also want to consider different kinds of deployments. If I have an eBPF deployment or a uProbe deployment, I can actually get a lot of things already from a visibility perspective. I can't enforce, but at least I get the visibility part. Sure. Any other questions? Again, apologies for being late. It was my mistake.